Today's lesson is going to be over sections 5, 6. We are going to take the derivative of the inverse trig functions. Okay, so let's remember what we've learned about inverse functions. Before a function can have an inverse, it must be always increasing or always decreasing. If you think about the trig functions, they are not always increasing or always decreasing. So the graph of sine x we generally draw like this. There's a min at negative pi over 2, a max at positive pi over 2. It goes up to 1, down to negative 1. So you can see that it's not always increasing or decreasing. It is not a one-to-one function. So what we do with the inverse trig functions is there is a certain piece that the function is defined on, and we just use that piece to find the inverse. So with sine, it is on the interval from negative pi over 2 to positive pi over 2. And what I'd like for you to do is open your books to page 372, and all 6 of the inverse trig graphs are drawn there. And I would like for you to look at them and study them. Look at the domain and the range. Remember, when you're dealing with inverse functions, you just flip-flop the x and y. So if this is the graph of sine x, the domain is from negative infinity to infinity. The range is from negative 1 to 1. I guess we include those, so I need to make those brackets. We want to include negative 1 and 1. But for the inverse portion, our domain is only going to be from negative pi over 2, again a bracket, to positive pi over 2. So if we are looking at the inverse trig function, which we write arc sine of x, our domain is going to be from negative 1 to 1, and the range will be from negative pi over 2 to positive pi over 2. So if we are looking at the graph of the inverse, we just flip-flop the x's and the y's. So the inverse graph, I am going to have the coordinate point 1 to pi over 2. So my y-axis will be in terms of my radians. And then I still have the coordinate point 0, 0. And then if I do the reverse of my other coordinate point, other endpoint, it is from negative 1, that is a 1, sorry, this is negative 1, to negative pi over 2. And we connect the dots, and there's the graph of our inverse sine. So this coordinate point here is 1 comma pi over 2, because this coordinate point up here was pi over 2 comma 1. This point down here is negative 1, negative pi over 2, because this coordinate point here is negative pi over 2 comma negative 1. to, on a nice piece of graph paper, sketch out all 6 of your inverse trig functions. If you're looking in your books on page 372, where there is no dot, you need to have arrows drawn. That means it goes to infinity. How this applies to our class is we are going to take the derivative of all 6 of our inverse trig functions. So you're going to have 6 new formulas. The derivative of arc sine u is u prime over the square root of 1 minus u squared. The derivative of arc cosine is negative u prime over the square root of 1 minus u squared. So the only difference between those 2 formulas is one is positive and one is negative. The other formulas are arctangent of u, which equals u prime over 1 plus u squared. So the derivative of arc cotangent u is negative u prime over 1 plus u squared. Our last 2 formulas, arcsecant of u is u prime over the absolute value of u, square root of u squared minus 1. So the derivative of arc cosecant u is negative u prime over absolute value of u, square root of u squared minus 1. So let's do a couple example problems. If y equals 3x times arc sine of 2x, you're going to have to use the product rule. 3x is your u, arc sine of 3x is your v. So we're going to do the first times the derivative of the second. The derivative of arc sine of 2x is 2 over the square root of 1 minus 2x quantity squared. U prime over the square root of 1 minus u squared. Plus the second times the derivative of the first. So if we simplify that, that's 6x over the square root of 1 minus 4x squared plus 3 times arc sine of 2x. Okay, so your homework from this section is to graph all 6 of the inverse trig functions. State the domain and the range. You can refer to page 371.